Welcome back. So we're going to be continuing our journey on studying C Sharp for Unity, and this is a very beginner's tutorial. Where we last ended off, we were talking about our list, but we had expanded on variables. Let's look at our variables. Where was the variables part? Okay, so I had stated that if we had made a special class, here we go. And because we said a class will hold variables and methods, and we create a special class called student, which contains three variables: a string for the student name, an int for the student age, and an int for the student class that they're in. And once we've got that set up, it's just another piece of information. This class is a piece of information that holds information, and therefore we can make that. If I go back over to my variables, um, right? So up here at the top where we said we had numbers, words, true, false, nothing. I also said that we can make it, here we go, up the top, student. Student can now be a variable type. And therefore, we can put in our little boxes, we can put, here we go. We can use student as a variable type, and we used it with a list. So we now have a list of students, and each student has a bunch of information about the student. We ended off there. The next part I want to go into, which I left off of my first list. Our first list, we talked about libraries, variables, methods and functions, putting questions in, which is using an if statement, or we learned the correct term of a conditional statement. We learned about classes and collections. And the collections were our list and arrays. And the last one I want to put in here is called loops. So a loop, very simply, is just a way to do something over and over and over again. And it is determined by a specific set of conditions. So we'll look at the most basic of them, which I guess would be the while, since it has the least conditions. So just like the if, we have those brackets there, which will take a condition. An if said if you open the brackets and you asked if something was true or false. It wants to know, while something is true, keep doing it. So I could say, well, let's say x is equal to uh, 0. And we're going to say, well, x is less than 5. It'll keep doing something. And I'm going to say, let's just say, type on screen x. And then after that, we're going to say x plus 1. So x gets plus 1 every single time we do a loop. So it's going to say, while it's less than 5, keep doing this over and over and over again. So which means at the beginning, x equals 0. That's less than 5. So we're going to type on the screen 0. Then we add 1. And then we loop back to the beginning. And it's going to check. Okay, is 1 less than 5? Because now x equals 1. 1 is less than 5. It's going to print 1 on the screen. And it's going to add 1. X is now 2. Goes up to the top. Checked. 2 is less than 5. Type x on screen. It's going to type it's 2. And now x is equal to 3 because we just added 1. Back to the top. It types on the screen 3. X is now equal to 4. And it's going to go back up to the top. 4 is less than 5. Type on screen x. It's going to type 4. And now x equals 5. And we're going to go back up to the top. And it says, only do this stuff while x is less than 5. which guess what? X is now equal to 5, which means it's not going to do any of this stuff. The only thing printed on the screen will be that. 0, 1, 2, 3, 4, and it'll never type 5 because 5 is less than, sorry, 5 is X is equal to 5, and we only want it to be less than 5. If we want to do 0, 1, 2, 3, 4, and 5, we would have to say less than or equal to 5. Yeah, less than or equal to 5. So when it gets to 5, it says, oh, is it less than? No. Is it equal to? Yes. And then when it gets to 6, it's no longer less than or equal. It's not going to do anything. Okay, so that's the first kind of loop there is. The next kind of loop is a for loop. The for loop says for, and we need to set up some conditions in this loop. And the first condition is we need to set up what it's going to be. Let's say X is equal to 0. All right, that is the first part. Semicolon or just comma? I think it's a comma. I'm just going to use commas. I forget how it goes. Normally it's automatically typed for me. So we're going to say at the beginning of this, X is equal to 0. And we want to know, when are we going to stop doing this? Well, we're going to say when X is, it's going to do this if X is less than 5, like we did before. So it's just like the while loop. And how does X change? If X doesn't change, we'll never reach 5. So we have to change X somehow. We're going to change X by saying X plus 1. Now this is not how it looks when we really do it. I'm just putting this there, saying we're going to add 1 to X. So I can just say plus 1. And then we do our loops. And over here, I had to say what X was. I had to say, when is it going to be doing the loop? And I had to say, how much do we change X by in order to stop the loop? That's the same thing that we've just done here. What is X? When does the loop run? How do we change X? So it's exactly the same way. So I don't need to put down here X plus 1. It's already done in the top. Okay, and the last one. So I use for loops. I don't use while loops that often, but I do use for loops. And then another one that I use quite a bit is for each. And let's open this, close that, open this, close that. Okay, where we use a for each is when we're doing these things. So if I have a list of something, I've got a list of students. I want to check, I want to print off the students' names. And so we have student and the class that we created for it over here, class student, has student name. I want to go through every single student and print their name on the screen. I can use a for each loop here or a for loop. And I'm going to show you in both ways how to do it. And let me drop these down a bit. Okay, so we're going to be going through our list of students. So we're going to say X is 0. And how long do we want to go? As long as X is less than the amount of students. So we're going to start at the first student, and I mentioned that when we're doing a list, the number, which is called the index number, so we give a number to each item going through the list, that number always starts with 0. So so we start with X equals 0, and as long as X is less than the students dot count. So we're going to count the amount of students, and as long as x is less than that amount of students, we're going to continue to do the list. And this is how we're going to write it in the correct way. X plus plus. That's a shortcut, which I'll show you when we get to programming. It's a shortcut to adding 1 to x. So once we've done this, I'd said that in order to get anything from a list, so students, we have to find its place. So 0, 1, 2, 3, 4. We have to find its place in the list and put that number of that place inside of these brackets. But let's take this and just shut this over because I want to say, let's say print on screen, and we're going to get that students list. We want to find each of them, so we're going to find x. We're going to put x in here because currently x is 0. It's going to find the first student, and I want to find its student name. So in order to find something more specific about students, I put a dot, and I'm going to say student name. So in this case, the first time around, x is 0. It's going to find the student at position 0 and write his name on the screen. Then we go and loop around again, and we find the second student, which is now x is 1. So we find students 1 dot student name, and then students 2 dot student's name, students 3 dot student name, students 4 dot student's name, and it keeps going till we get to the end of the list. This is how we would set this up if we were doing a for loop. In a for each loop, it's going to be set up this way. I don't know how long that's going to be. So we need to find a collection, which will be our list called students. So we say for each, let's just say something in a collection. That's pretty much how a for each works. Or let's say for each thing in a collection. So for each of the things that you find in the collection, we're going to do something with that thing. Now that thing is a variable. It's a piece of information that is found in a list. So that thing could be a student. And we are going to need to have a variable name. So it's a type of information. We created student. Oops. We created student as a type of information. So I can put that here. That's a type of information. Oops. Back to there. And we need to give that information a name, a variable name. Let's just call it STU. And I can say in students. Students is the name of the list. So for each student, we're going to call it stu for now. In students, do something. And here's where we use the variable is inside of here. We're going to use that variable by saying print on screen STU. That's the student, but the student is broken down into dot student name. Okay. This looks a lot easier than this. This has a lot of code going on here with the x equals 0, x is less than students dot count, x plus plus, and then using this part here of the square brackets and the x. So this looks a lot easier. We're just saying for each student that we find in students, print the student's name on the screen. And it does work a lot easier, I find. Sometimes, though, we do need to use a number. But if that's the case, I can just say x is equal to 0 and x plus plus. I can do that, which is what we did in the for loop. Sorry, in the while loop. So it's bringing back something from the while loop. But I do tend to use for each a lot. Okay, so I wanted to get through loops, and specifically the loops that you're going to see me using a lot in my tutorials. And zoom out. That's it for working in this kind of way. I now want to move on to working in Unity and actually showing the real scripting. So let's move over to, let's get OBS out of the way. And let's get to our work screen. Means I need to turn off Leonardo. There we go. Okay. So here we are in Unity. And when it comes to coding, we're going to look at our project. And this is how we're going to set up our code. So I've got a folder for C# tutorial. I'm going to right click in here, create C# script. Or if you want, there's a little plus sign here. And I click on that, C# script. Now this is an important step. When I click on this, it's going to be waiting for a name. It hasn't set up the file yet. Normally when you are just creating a C# script, you can have it blank, absolutely nothing in it, and fill in all the code yourself with the important stuff that you're going to need, which is the libraries. You're going to need to start the class, and you're going to need to put in your variables and your methods and everything. For now, it's waiting for me to give it a name, and this is an important step. If I hit enter, it will accept the name new behavior script. So I'm going to hit enter, and then I say, oh, I don't want that to be my name. So I click on this. Now, what you're going to notice here is, now that this is selected, it's showing me the code over here in my inspector. And one of the things to note is it's used the name, new behavior script. Here it used it, new behavior script. So the class, oh, come on, do what you got to do. Right. The class name is now new behavior script. That's the name of this class. If I change this to my first script, and I always use camel case in naming my scripts with a capital M at the beginning. Let it compile, and watch what's going to happen now. Okay, if I try to use this, I'm just going to drag it on to, let's say, the camera. Drag that up here to the camera, and we have an error. So the error is because this is called my first script, but over here, the class name is still new behavior script. It hasn't changed it, and it's having a mismatch. Unity and the C# script cannot communicate because the C# script should be the name of the file, and we've renamed the file. So that's not going to work. Delete this. Yep. Okay, when we're creating a new C# script, after this updates, thank you. Okay, when we're creating a new C# script, we are going to click on this, and so we see it highlighted in blue. It's waiting to be typed in. With quite a few of my students, I always tell them we want to be as efficient with our time as possible. I see quite a few students hit the delete key and start typing and hit enter. And now that is the name. Okay, that's one way. delete this again. Update scripts. Hold on. And create another one. Okay. That hitting of the delete key, one keystroke too much. It's ready to be typed. It's highlighted. If I just start to type, it types over whatever is highlighted. I don't need to click the delete key. That's a very simple thing, but it's still good to know that you don't have to waste your keystrokes. Hit enter. All right. Now we have my first script. It's called my first script in camel case. And hold on one moment. Sorry, I forgot I set my alarm and I don't want music playing in the background for copyright issues. Okay. I was saying, I'd named this my first script, and there's my first script. And the names are the same, so we have no problem. If I took this and go away. If I took this and drag this up to my camera, it's now on the camera. There's no error. If I click on this, I can see there's my script. I'm going to delete it because I don't want that on the camera. Okay, double clicking on it will open Visual Studio. Visual Studio is, it comes with Unity when you do an install of Unity for the first time. And it's where we do all of our programming. And we need to be careful of one specific thing. I've seen this happen in some cases. All right, so if we come in here and Unity has auto-filled some things in. We're going to look at them in a second or two, but if we came in here, always look at the colors of things. I want start and update to be this kind of blue. If I don't see that, something's not going right. And I look up here, this says RPG Starter Tutorial because the name of our project is, where is it? RPG Starter Tutorial. That's the name of the project. When I open in Visual Studio, it has to have a link between Visual Studio and the project. If this says Solution 1, something's gone wrong. And in order to fix that, because if you start typing here, if I did that, I'm going to get these options of possible code. If I don't see that pop up when I'm doing something that's specific to Unity, it means there's no link to Unity. And that would say solution 1. And the way to fix it is that you would have to close down Visual Studio. So you shut it down. Don't save. You'd come into Unity. You're going to go to Edit, Preferences. Where is it? External Tools. And then up here, it's probably going to say Open by File Extension. And you want to select Visual Studio, the version that you have. I have 2 versions installed. Obviously, I want to be using the latest one, which is 2022. So I'd select that. And once you have that selected, you can then go back and reopen Visual Studio. I don't think it's going to ask you to restart your project. I haven't had that error in a while. I have seen it happen to some of my students. I don't think they restarted. Okay, now we are in Visual Studio. All my colors are good. RPG Starter Tutorial is up here. And we're ready to start learning our coding. Let's look at what we had discussed in our lessons. So for our lessons, for our lessons, here we go. And Leonardo, good. Let's look at some of the things that we talked about. First one we looked at was our libraries. And let us go back to OBS and let us look in our code. Why is that? I want Unity. Well, that good. All right. Here's our libraries at the top. Using systems.collections, using systems.collections.generic, using Unity engine. Now this one here, if we're working in Unity, that's normally a very important one, using Unity engine. Next, we talked about variables. Then we talked about methods. Then we talked about if statements. And then we talked about classes. Here's the class. So I described the class as a piece of code that holds variables and methods. Here is my class. We're going to be putting variables and methods inside of the class. When we talked about classes, we said a class could save on space by not printing all of its code in one area. We could put code in somewhere else and tell our class to get code from that code. Here we have, here's the name of it. So it's a public class called my first script. And mono behavior is a place where things are stored. Lots of code for Unity specific code are stored in mono behavior. And I don't have to have all that code showing here. I'm just saying that my first script gets this code. I can use whatever code is in here because it's stored in there, and this guy is going to gain that code. And I don't have to see it here. All right. Then variable. Let's do our first variable. And we're going to say this is a float player speed. So that's the name of my variable. Anytime we see anything being underlined in red, and I'm seeing down here, there's a little X and a 1, meaning there's an error. I look up here in my scroll bar, and I see there's a little red dot that's showing me where an error is. And I look in my screen, and I can see a little underlining saying there's an error here. And the error is we finish every line of code with a semicolon. The semicolon in coding is the same thing as a full stop in the English language, or in most of the languages. If I did this and I said float player speed, this is fine. I never ended the line float. If I said float that, I should get an error. Yep, see, I'm getting error because it says, oh, I don't know. You can't just use float. You have to say float and a variable name. So you can't just do that. That's an error. And player speed is a variable name, but it doesn't have a type. That type is ended. This line is ended. This line has nothing to do with this line. So this line is saying, here's my variable name, but I never said what kind of variable it is. If I did this, this is fine because I'm saying float. I never end this line. Player speed, which means float comes before player speed, which is correct. That's the same as doing this. Float player speed. Okay, we've created our first variable. Now we know a little bit about variables, that we have to have a semicolon on the end of all of our lines. A method, which we see down here, void start. That's the name of the method, and we can input information into the method. We've got another one called void update, and whenever start is run, whatever's inside these brackets will run. Whenever update is run, whatever's inside the brackets is going to run. And when we see these two slashes and green text, this is called shoot, just trying to remember the real name for it. It's called a comment. It's just a little note that you can leave behind. And all of this stuff was created by Unity, except for this, which was just created by me. So all of it was created by Unity, and Unity put in two little notes for us. If you use Unity enough, I usually just delete the notes. I don't need them. But Unity is the one that calls start, and Unity is the one that calls update. And it's going to call start at the first frame of update. Okay, so let's look at update and see when does update run. Update runs every single frame. So once a frame, it's going to run. And that means that if you're a gamer, you would know about frame rates. And a standard one is 60, but a lot of people are like, oh, I've got a game, I could play it up to 120 frames a second. Unity, by standard default, sets its frame rate at 60. So we're looking at 60 frames a second. Once a frame, something's going to run in update. It's going to call this once a frame. That leads us back to this guy, start. On the very first frame of the update, whatever's in here is going to run. Only on the first frame. Then update takes over. Okay. So these are two methods that we have, and here is our script. For now, I'm going to remove update. I don't want update for now. I'm going to keep start. And we're going to start looking into some of the things that we've learned. One of the things we learned was we were doing our variables, and I'm going to say that I want a, let's do a string, and this will be student name. Okay, that student name can hold one name. If I said, and I could add it up here, student name is equal to Bob. And I'm going to save this, and that print to screen part that I kept writing, the official way to write it for Unity is debug.log, and inside of these brackets goes whatever I want to print into Unity. And I'm going to say, I want you to print whatever information is in student name. And here we see we ended our line off with a semicolon, so we know we're done with this line. Print whatever's in there into Unity. So save this. Let's go back to Unity. Okay, did it update? No, it's updating. When you're wondering what's going on, usually you look down here, you see a little wheel turning, and that just means it's thinking to do something, reloading its script. There's not much in that new script, so I don't know why it's taking so long. Okay, here we have our script, and the script needs to be on an object to run. It needs to be in the scene to run. That mono behavior part of it, here is the mono behavior part, that's going to need to be in the game in order to run the start. It needs to be a part of the game for start to work. I'm just going to create an empty object. I'll call this script tutorial. And we'll put my first script onto script tutorial. There we go. There's my first script. It's now part of the scene. Just reset this. Reset. There we go. All right. If I run the screen, where is it going to show up? It doesn't actually show up in the game. It's not a part of the game. That debug.log is just something that programmers will use in order to test certain information that's happening in the code. And it comes out in this place called console. So I'm going to see something pop up here. Let's hit play. And it happens on the first frame. So as soon as all this has compiled and the game runs, it'll happen on the first frame. And there it is. Okay, it printed Bob. All right, let's go back to here. And before I print something on the screen, I'm going to do this, and I'm going to say, now once I start typing, Visual Studio is going to be helping me out. I start to type, and it's looking for all the code that could possibly fit what I'm typing. So when I started S, it gave me a whole bunch. Like it gave me string, there's struct, and then there's student name. As I start to type more, STU, there's student name, there's stack track utility, but student name is at the very top. It's assuming that I want student name. And it's also saying, oh, I might want an equal sign after student name. So it's saying hit tab twice to accept this in gray. Basically, Visual Studio is learning the way I program, and it's giving me suggestions. So I can say tab tab, and now I can say, oh, let me show you this. Frank, but unfortunately, it underlines Frank because this is not a string. I need a string. And if you remember correctly, I said we need to have double quotes for something to be a string. Right now it's saying, I have no clue what Frank is. Student name is supposed to be a string. Please give me a string. So I'm going to double click. I'm going to open, close my quotes, and put Frank in here. No more red underlines. We're all good. What we've done is we start student name as Bob, and when we printed it, it printed Bob. But student name could only hold one name. I put Frank in there. It means Bob is no longer in there. Let's take a look at that working. I did click save, right? Yes, I did. So in the console, let's hit play. It'll no longer be Bob because we told it to use Frank. And we did the replacement before we told it to print it on the screen. And there we see Frank. So it did the correct thing. It started with Bob, we set it to Frank, and then we printed it on screen. And if I did this, student name equal to Tom, oops, Tom, the thing that's going to be printed on the screen is Frank, because we said change it to Frank, then print it on the screen, then change it to Tom. We never told it to print it on the screen after we changed it to Tom. We read from the top down in all of our code. Tom came after the printing on the screen. So Tom, yes, the variable is Tom, but we never told it what to do with it. We never told it to print it on the screen. Okay, let's get rid of all of these. And we're going to expand on what we were doing. Let's look at a method, a very simple method. Void, this is a method, not a function, so it doesn't return anything. And I'm going to say print name to console. And there we have our first method, which is going to print a name to a console. And we did that just now. Debug.log, and I'm going to print student name. I'm going to get it from the variable up here, student name. And let's run this. Some people are smirking right now, and you'll see why. People are laughing. I'm going to run it, and watch what happens here. And voila, absolutely nothing happened here. And why was that? We created our method. Here's the method, and it's supposed to print to screen, but we never actually ran the method. Creating a method is just saying, I've got a bunch of instructions, but I never gave the instructions to anyone. I never told anybody to do the instructions. I'm going to copy these instructions. I'm going to copy the name. Now, start, we know start runs. That's a method that works. Unity is the one that runs that method. So when start runs, it's going to do whatever instructions are in start. I'm going to put that in start. So start runs, and he says, oh, what do we do? Oh, we're going to run this method, which is down here. Now we should see that when we do this, when we run the start, when Unity starts that first frame, it says, oh, go get that method and run that method, please. And that method is going to look for the student name, which is Bob. We didn't change it in this method. And there's Bob. So the method printed Bob on the screen. That was a simple method. We're grabbing this piece of information, this variable, from up here. But it means that if I did this, and I did it twice, it's going to print Bob twice, because it says, get that piece of information. If I said, student name is equal to then it means that the method's going to run. It's going to change. So here's the first time the method runs. It changes student name to Tom, debug.log, student name. It's going to print Tom. The second time it runs, it's just going to do that again. It's going to put Tom in student name, and it's going to print Tom. So Bob is gone. So the method runs the exact same both times. That doesn't make for a very good method. I want a method that I can run multiple times and get multiple different things. Let's not use student name anymore. I'm going to create a way to put information into the method. I want to put a string into the method, which I'm going to call underscore student name. So this is different to this. I've got an underscore before it. So it's a different variable. And instead of using this variable down here, I'm going to use this variable in here. Okay. Now we see up here where I'm running the method, it's underlined in red. It's saying something is wrong. Because I put this here, the method must have a string going into it. And I do that in the brackets. And I can say Bob. Once I've done that, once I put a string in the brackets, that's no longer underlined. It says, okay, this is the correct format. If you change the format of something when you're coding, you're going to get errors unless you have the correct format. Now I can go and say Bob, Tom, Billy. So these three names here, I'm running the exact same method, but the method says whatever is in here goes all the way down to here, and whatever's here goes into here and is used in here. So I'm saying Bob goes to here, and it's going to print on the console Bob. Then Tom goes to here, prints on the console Tom, and then Billy goes there as well. All right, let's save this and run it. Getting an error. Oh, okay. That's an interesting error. I'll come back to that one. All right, but we see here it says it's printed Bob, Tom, and Billy. The method ran 3 times and we inserted a different name each time. Okay, let me see if I can get that error to come up again. There, no, make a change. Okay. And the error should come up. It's not an error, it's a warning. The warning is telling me that my script says the field, my first script, student name. That variable we created called student name, it's assigned, but the value is never used. And that is very true. Here, I said student name equals Bob. I've assigned this. The script knows I have a variable called student name, but nowhere in here do I use student name. One of the reasons it might be telling me that as a warning is because once I've created this, it has reserved a place in my memory to store something, to store Bob. What if I didn't have that powerful of a computer? Every single variable that I create that it's reserving memory for is a waste if I don't use it. I'm not using that, so I don't need that. I don't want to waste my memory. That's why that was giving me an error just now. It was, sorry, not an error, a warning. Okay, I've got a variable, sorry, I've got a method, and the method works, and we were able to insert information into the method, making this method a very strong method. I don't need the method anymore. Let's get rid of it. I'm now going to do a function. So a function has to return information. I'm going to say that I want a function called add two numbers. And the kind of numbers that I'm going to add are going to be, and it's underlined because I'm not finished with it yet. I'm going to insert an int, and as I said, an int is a whole number. So an int called num1, and I want two numbers. So another comma, int num2. So I can insert two numbers into it. Now, it's underlined in red because it says, oh, I have to tell it what information is coming out before we use void. So I can go ahead and say debug.log num1 plus num2. Getting no errors. What's going to happen is if I run this now, oops, and I need to add my numbers in here. Let's say 3 and 6. So I'm going to run. This is still a method because of the void. And it's going to be printing it on the screen. Play. And we're now seeing an answer on the screen. It's now saying 9 because I said to add 3 and 6, and that gives me 9. Okay, now let's turn the method into a function. So the function is not going to be printing it on the screen. That'll happen in start. I'm going to say debug.log, and then I'm going to put this inside of here. And it's giving me an error because this is a method and this is not a piece of information. This is something I can run, but it's not information. In order to make that information, this would have to return information. And I'm going to return the addition of two ints is an int. I'm returning an int. Okay, now this is fine. Now this says, oh, well, I know that this is supposed to be returning a number, so I could debug whatever number this is going to be. But this isn't fine. This isn't working because it's expecting to return a number. And I've got no returns. I'm trying to print to the screen. So I'm going to have to say return, and see, it's already told me what I want, num1 plus num2. And now, no red underlines, it's going to do the addition, and it's going to return an int. And then up here, I'm going to say debug.log, run this function using these two numbers, and print that onto the console. Save, and let's go back. Hit play. And there we go. We see the number 9 has been printed to the screen. Drop it. And here. Okay, so this is powerful because it means that I could insert stuff in. It can do a whole bunch of work and return something back out. And that gives this a lot more power than the method. However, not all the time you need to return something out. Sometimes you just want it to just do stuff and that's it, which makes both method and, so if I did both of these, void, so I'm going to put this as add two numbers f for function and add two numbers m for method. I'm not returning anything. Notice the return is now underlined because we're not supposed to return anything. Okay. Both of these do the exact same thing. If I ran this like that, 3 and 6, I get the exact same result doing that and doing that. There are times when you're going to find where a function is needed and where a method's needed. That's just something that it's hard to kind of teach it right now. It's when you're working for a while, you start to know which is better, using a method or a function. All right, so that's our method and our functions. At this point, we would have gone back to, oh, we did if statements. So let's create, I don't need these anymore. Let's get rid of those. And let's do it in start. Okay. Let me say that student name is equal to Bob. And let's go into start. Oh, I accidentally deleted. Always remember if we open a bracket, we got to close a bracket. So I had deleted that one by accident, which meant we opened this, close that, but then we never closed that one. All right. So student name, oh, it's having a problem because I need to type that it is a string. There we go. Now let's ask a question. If, no, I don't want that. So I want to if, and inside of here, I might ask a question. The question is going to be if student name, and I mentioned this before, if I use 1 equals, it means I'm putting something into student name. If I use 2 equals, it means I'm checking to see if student name is equal to something. And I'm going to say if student name is equal to Tom, do something. And we're going to print on the screen our printing console, debug.log, my name is Tom. If we run this now, we're going to notice that we know student name is equal to Bob. It's not equal to Tom. So whatever happens to those brackets should not run because it's not equal to Tom. Only what happens in those brackets will run if the statement was true and the statement is false. So we're wasting a lot of time here just seeing that nothing happened. All right, we go back. I'm going to change this to Tom. Now this is going to be true. Student name is equal to Tom. It will print my name is Tom. And now we see it printed, my name is Tom. Okay, so that's our conditional statements, our ifs. We use these a lot in programming. When you go through my tutorials for the RPG starter pack, that you're going to see tons of if statements being used all over the place. And that's how it goes. If something's equal to something, then do something. What if it's not equal to that? Well, I could say else, and I could do something else. Debug.log, my name is not Tom. So notice before, when this was Bob, it did absolutely nothing because it told it only do something if that's true. But now we're saying do something if it's true, but if it's not true, do something else. And now, since it's not true, it's going to print this. My name is not Tom because it's Bob. Okay, I'm not going to go through that because let's carry on with some new stuff. But if you run that yourself, you'll notice that it's going to choose the second option rather than the first option. All right, we've got a student name variable. Now we're going to go and create our own variable. I'm going to, actually, before we do that, I need to get through with one more thing. And this we did not do in our notes. And I have, as part of this script, a variable called student name. And let's look in Unity at my script. I can see the script here. So regardless of this loading, there's my script. And there's nothing really printed on this script. What if I want to change the name of the variable, student name? I want to change the name. I'd have to come into here and change the name. But constantly doing that will get tiring. I want to see this variable showing up in Unity that I can make the change from inside of Unity. Then I need to be able to access this from outside of my script. Here's the first way that is a Unity that will work with Unity is to say serialize field. Okay, this allows me to access this inside of Unity outside of the script. Okay, and there it is, student name Tom. So I can now say Bob. I can make that change, call this Bob. Means I don't have to keep coming in here to change it. So I can say Bob, I can say Frank, whatever. Even though this is being done in the script, it's being overwritten by whatever I put here, which means I don't even need this here. I can get away with not having that because Unity is going to set the student name before the game starts. That's one way for me to see it in Unity. Now, I'm going to show you the other way because this is allowing me to see student name in Unity outside of the script. But let's try to access this script from another script. I already have item SO open. That's a script that I had. In fact, let's close that because that deals with the more advanced stuff. Let's create my second script. Create C# script. My second script. Okay, and it is stored right here, my second script. There we go. And I'm just going to get rid of update. Don't need that. Don't need that. And I want to be able to access the first script. Well, I could just call it by its name. My first, and there it is, my first script. And I want to get something specific about it. I want to get the student name. So when you want to get something specific, you put a dot. And I'm going to start typing student, but it does not show up. We already said that we can access this outside of the script. We're accessing it from inside of Unity, but why is it not showing up here? And the reason is this statement allows me to see that in Unity, only Unity. What if I did this? When I take that away, I can't see it in Unity, and when a variable has nothing before the type, it is known as private. This variable is a private variable. It can only be seen by my first script. I can use it anywhere inside of my first script. So that means that I cannot see it in my second script. Adding that allows me to see it in Unity, but nowhere else. I need to now set this as public. Once I set that to public, it means that I can access this outside of the script. So my second script dot now, wait, my second script dot wait. Oh, I'm in my second script trying to access my first script. Sorry, my first script dot, and it's not letting me get it. Why? Public string student name. Oh, okay. I know why. Okay, and that's gonna be more of an advanced thing. That it has no reference to this. This is not linked to that. It it needs to say, oh, well, you're talking about my first script, but I don't know which my first script you're talking about because I put my first script on here. We duplicate, 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 duplicate. Now then, my first script is on this, 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 and this. Which my first script do you want? This one? Maybe this one where student name is Tommy. Maybe you want this one where my student name is Bob. Which script do you want? That's why that's not working properly. I can get to that later. What I wanted to say though is that when I do have this as public, it allows me to access it outside of this class. Now, when I create something here, let's say start. I'm going to create a variable in here, and start is part of this script. I cannot say public int num1 equals 5. Cannot do this because any variable created inside of a method. So I've got start. I'm going to do void my method, and I'm going to, right now it's really bugging out because it knows I've got a lot of errors. Public float num2 equals 5.6f. I put an f on that number so it knows it's a float. I don't think I have to do it anymore, do I? Yes, I still have to do it. Okay. But all of this is giving me errors because there's an error right here. That public. I remove, now that's fine, but now it's giving me an error down here. I remove that. This is a private variable, and this is a private variable. And they're so private. Now let's put this back as, let's do another variable here. Let's do an int num3 equals none. Okay, this is also a private variable. This variable cannot be seen outside of the script, but this variable can be seen anywhere inside of the script. This variable is created inside of start. This variable can only be seen inside of start. So if I want to say debug.log num1, that's perfectly fine. I can do that. This variable is created inside my method. Debug.log num2, that's perfectly fine. Now, let's add num1 and num2 inside of the method. So let's do this again. Debug.log, we've got our num2 in here already, plus num1, and now watch, error. It doesn't know what this is. This variable is private to start. This variable is private to my method. I cannot use this variable outside of my method. So I cannot use it in start. Just like I cannot use num1 in my method. Oops. There we go. Right. I cannot use num1 inside of my method. I can use num2 because num2 is made in my method. And I can use num3. Num3 was created outside of methods, which means num3 can be used anywhere inside of these methods. It might not be able to be used outside of my first script, but it can be used anywhere inside of these methods. All right. Get rid of all of this, get rid of this, and get rid of this. Oh, just that for now. Okay. I'm now going to create a brand new class because I want a brand new type of variable. I have a variable called student name that is a string, but what if I want to create a variable that contains many different things? We looked at that in our work before, and I'm going to say this is going to be a public class, and it's going to be called student, and it wants information now. I want information that I can get outside of this student. And I'm going to say public because I want to access it outside. And this will be the string and student name. And I want public int student age, and I had public int student class. Either class 3, class 4, whatever. Okay, save. I've just created this thing called student, and it is now going to be a piece of information. All things are pieces of information in some sort of way. So instead of having the student name, I'm going to say public student, and let's call it student info. All right, the name of the variable is student info. What kind of information is? It is student information, student type. So student info will contain all three of those things. And this is public, which means I should see this anywhere. But let's just do it as how we did it before. I want to say it in Unity. Serialized field. Save. Now, it's going to be a problem. I'm going to go back to Unity, and that's going to disappear. Student name's gone because we removed student name with student info. And once it reloads, let's just get rid of all of these. I don't need those. Get this. Right. There's nothing showing. Even though we set that serialized field, there's nothing showing. It's because this guy here, he's got some public stuff. That's going to allow me to access this stuff, but only in code. This guy here, Unity doesn't know to show him on the screen. I have to tell it system.serializable, and it means that this can now be shown. I'm telling it that whatever comes after this, which is student, can be shown. So system serializable allows me to show that in Unity. We will save and we'll take a look at it. And now we're going to see written here the word student info, which is the name of the variable, and then it's going to be broken down. So here's the script, and there we see student info and a little toggle. And we now see student info consists of 3 different things: name, age, and class. We have a brand new variable that can store multiple things. Okay, I'm going to leave that there for now. And I'm going to go on to our next topic, which we had as collections. I'm going to say, and I'm not going to go through the array collection because most of the time you'll find me using list collections. Both of them do kind of work very similarly. So I want to say I want a list, and it's already giving me some options. List of students. So I don't want to do that just yet, though. String. And I'm going to call this student names and that. I've just said I want student names to be a list. So it knows what kind of information it's going to be. It's going to be a list of strings, but there is no list yet. Well, I can remedy that by saying it's equal to new list of strings, and that's my remedy for that. So I've said I'm creating a variable that might be a list of strings, and now let's create a new list and set that to being the new list. Save, and it is not going to be viewed in Unity until I add certain somebody. There we go. Save. Make it all nice and neat. Now we can look in Unity and see a list, and this is what this would look like. And remember, it's only strings that we're putting in there. And here's my list. I click, list is empty. I create a new list, but I didn't put anything in it. And it's saying here, there's 0 items in the list. I can add the items here, or I can type in a number here. So let's add 1, 2, 3. I can see now it says 3 items. We've got Bob, Tom, and Mark. Good. Now we have a list of 3 things. And I could have added those things using code, or I could have added them just using student names. Let's try and add using code. I already have 3 things in the list. I'm going to add a 4th when the game starts. I'll say student names dot add, and add a girl's name here, Mary. So it's got 3 things, and when the game starts, it'll add Mary. So let's go back here and take a look at it. And naturally, it hasn't added Mary yet because the game hasn't started yet. We start the game, that's when the code's going to run. And now the game has run. Mary has been added to the list. So we can add things to the list in Unity, and we can add things to the list in code. And take a look at this. These are called element 0, element 1, element 2. Remember I said each of them gets a number. This is going to be number 0, number 1, number 2. I could reorganize this. Let's make Mark the first. Push him up. We see element 2 at the top, right? When I let go, it has renumbered them. Mark is now 0, Bob is now 1, and Tom is now 2. It always works in that order. So no matter what I do, it reorders the numbers. Let's look into making a more complex list now. So rather than student names, we're going to call this students in class. Oh, let's just call it students, plural. And what kind of information is it going to be? Just names, just a string? No, we want the full thing. I'm going to use student as our information type. I can remove that now. I don't need that anymore. And now let's go look how the list looks now. Remember before we had the student info with the 3 things on it. When we look at student names, these are going to disappear because I've changed that type. Because it's no longer strings in the list. So this list will go back to 0 now. So back to 0, empty list. Now let's add 2. 1, 2. It's not giving me any word type because these are also drop downs. There and there. So my element 0 now is the student info. My element 1 is the student info. It's all the stuff about that student. There's a peculiarity with Unity and doing lists this way. If I said this is Mark and this is Billy, this is what happens. Where it said element 0, it's now replaced with Mark, and this is replaced with Billy. This is still element 0, but they've made it easy for me that when I have my list all closed up like this, I can see things easier. That only happens if a string is the first thing. If I had age first and name second, that would still say element 0, element 1, because it would reorganize them. It says I'm only going to put a name here if a string is my first element inside of the student name or the student info. Okay, we now have a list with student info. And we've added 2 people in. Let's do something with this list now. Oops. See? The last thing that we did was we did loops today. Let's use a loop. And I said the first 2 that I love to use are the for each loop and the for and the for each. I don't use while that much. So we're going to start with the for loop and then the for each loop. Because of the version of Visual Studio I use, I type for, and then I can hit tab, tab, so I tab twice, and it's going to insert all this for me. That's why I couldn't remember. I put this as a comma, my mistake. It was, I put it as a semicolon first, and then thought I was wrong and put it as a comma afterwards, but it's a semicolon. Okay, so we're setting up our variable, I. In our demo, we use an x, but we're going to say I, it's an int, and it's equal to 0. And as long as I is less than, let's grab students, students.count. It's going to count the amount of students. As long as it's less than the amount of students, we're going to do whatever's in here. And every time we're finished with doing something in here, I++ means add 1 to I. That can be done in many different ways. For instance, I could have said x, no, int x is equal to 0. And then I could say x is equal to x plus 1. Or I can say x plus equals 1. Or I can say x plus plus. All of these mean the same thing. X plus 1 will be equal to 1. So x is equal to 0 plus 1. X is now 1. So if x is now 1, we're going to say x plus equals 1 means whatever x is, it's going to be equal to adding 1. And we know x is already 1 because we did that in the line before, which means this is going to say x equals 2. Now, x is equal to 2. X plus plus just is a shorthand way of saying x plus 1. Therefore, therefore, x is now 3. However, all 3 are exactly the same. All 3 of these do the same thing. Add 1. They all add 1 to x. They're the exact same thing. So if all of that, that's just me saying I plus plus means whatever I is, add 1 to it. Okay, now we're going to be looking at students, and I want to print their names off. Debug.log, and I'm going to grab my students list. And I need to get whatever's in the position of that list. If I said 0, that's the first position. 1, that's the second position. I need to get whatever's in the position of that list. And I'm going to be grabbing I, because I is 0. And the next time around, I is 1. And the next time around, I is 2. So I'm only going to run twice, because I only have 2 people in there. Now, what do I want to get from students? I want to get something more specific. So dot student name. I could put age. I could put whatever. So if I run this now, save and run. Sorry about my squeaky chair. Okay. Console, I have Mark and Billy. Hit run. It's going to execute the printing on the screen twice. And there is Mark and there is Billy. So it printed the names there. And it did them as 2 separate runs. It ran first, ran again. Okay, that's using the for loop. I'm just going to keep that there for now. So I need to separate it. Let's just do this. And now we're going to use a for each. So just like in the for loop, I haven't even typed everything out yet. And I'm just going to hit tab, tab, and it has printed everything out for me. So it's saying there's going to be a variable type, and we're going to give it this name, item. And that is going to be an item that is in the collection. Our collection name is students. And the type of information is student information. And the variable name we're going to give to each piece of information, let's just call it stu, like in my example. So now for each item that's in students, we're going to call it stu. So I can say stu, give me the first item, and then it's going to run it again, the second item, and it's going to do it for each of them, and it's only going to stop when it reaches the end. So stu dot student name. What are we doing with this? Actually, we're doing a debug dot log stu dot, nope, not the age, name. Okay. Now let's compare the two of them. This has a lot of involved stuff going on. I plus plus, I equals 0, like making sure students dot count, having to do this to get it from the students. This is a lot easier to read. That's why I like to use the for each more, because I like to say that student stu in students. So I'm just saying, look in students, and we're going to find a student, and we'll call him stu for each one. So we're just going to store that first information, second information, third information in stu. and it's a lot neater. And now I can just say stu.student name, a lot easier to write than students I.student's name. All right, save. For loops do have their place. I do use them, but typically when I'm going through a list like this, I'll use for each. Now, they both do exactly the same thing though, which we'll see right here. Right. We can see Mark and Billy, this was my for loop, and then there's my divider, and then Mark and Billy. They both work the exact same way. It's just how much coding do you want to do? What is useless? At some point, I might want to put debug. I'm going to say student, and then I want student. I want to say student 1, student 2, student 3. So student plus I plus space is named plus student name. Okay, so this line is going to print onto the console the word student. It's going to add on the number. I use a normal I is named, and then it's going to print the student name. Save. That I comes in useful because when I print this now, and run it, okay, let's look up the top. Here we see student 0 is named Mark. Student 1 is named Billy. Because remember, the I keeps going up. So that number is going to go up with it. Down here, we never did anything for down here. So we still have just Mark and Billy. And the thing is, this doesn't have a number that goes with it like this did. That I can be useful. If I want to do this just like that, so let's just grab this line here, replace that. I'm going to replace stu with this. I'm going to get rid of that. Now, we don't have I. Let's use an x. We also don't have x. So before the for each, I can say int x equals 0. I've now created an x. And after the line, I'm going to say x plus plus, which we learned from before that plus plus means add 1. This will do the exact same thing as this. And I also tend to do this because, I don't know, this for each just runs easier for me in my mind. It's just an easier way to create loops than the for loop. And the for loop has, yes, less lines. That's 4 lines there. 1, 2, 3, 4. This is more lines. 1, 2, 3, 4, 5, 6. Still, I like to go with the for each loop. I don't know. It's easier to see and easier to read. I don't know. All right. That is our loops. That pretty much brings us to wrap up what we had prepared in our we prepared all of that in our plan when I was in Leonardo. This should help you a bit with understanding some of the code that I've been doing when I was doing, so for instance, let's look into one of the pieces of code and see what we have. Well, let's see, player. Okay, so here's a player. And ignoring the first line, we'll look at the second line. So data type is a float called player speed, and we're setting it to 5, and we're saying it's public so that we can access it from outside the script. The next is public rigid body RB. So the name is RB, it's public, and the type is rigid body. We haven't seen that before. That is a variable created by Unity, and it's the same exact same thing as when we did this. Public class student, and we use student as a variable type. Unity has created something called rigid body 2D, and it's got variables in it, and it's got methods in it. I could put a method in this too. I could say void change name, and we'll input a string, the name, because remember, classes hold variables and methods. And I'm going to say that student name is equal to the name. So now student is a variable. See, we're using students. It's a variable. We can use them. And we can say that we have a method inside of there. I believe I have to make this public as well. All right. And now let's run the method. So before we do any loops, I'm going to say that, not going to clear the list, but I'm going to say students, and I want to grab the first student, who I think I've said is Tom, dot change name, and I'm going to input Sarah. So I've created that this guy here has way more power because I can actually go and change those names using code. So the first person, I'm going to run a method called change name. That's going to change the list. So there, it's Mark. So Mark is now going to become Sarah before I do my loops. Run it, and we're going to see in both of the loops the name Sarah pop up. And there we see name Sarah. Down here, name Sarah. Okay. So, oops, nope. What I want to go back to. I want to go back to this. Right. So when we saw in here, and just get rid of that. Save. Save this because I don't need it. When we see in here rigid body 2D, that's something that we're finding from mono behavior. That's something that comes from Unity. And so if I get rid of this, that should go away, I think. Should give me some errors. No. Okay, transform gives me an error. So that's coming from this Unity engine. All right. So what is rigid body? Well, it's just a collection of variables, just like student was a collection of variables. If we look in our scene, and where's my player? Saffron is the player, and here is rigid body 2D. And if we look at this, ignoring some of these other ones, because these are variable types we haven't looked at yet, we have a bool, which is true or false, simulated, and a check mark. That's true or false. Use auto mass. That's true or false. Mass. This is a decimal place number, which means that's a float. Linear drag. I believe it's also a float. Angular drag, gravity scale. These are all floats. Down here, we see we've got some more check boxes. So basically, a rigid body 2D is a collection of variable types, just like how student was. And we can use it as a type of information for RB. Animator, same thing. Vector 2, same thing. Except this vector 2 is private because I did not put public before it. And here we have, so I can store a game object. Here's an if. I'm asking, Null means nothing. It's kind of like void, but a different way of saying void. But null means nothing. So I'm. This is what this line says: creating a variable called go. And what goes in go? A game object goes into go. An actual object in my game can go into go. And what's it going to be equal to? Well, it's equal to find this thing here. So whatever this is, pm.instance.scene destination, it's finding something, and if it finds a game object, it's going to put it in here. Now I'm asking a question. If the game object is empty, in other words, I didn't find anything, then return. And return means don't do anything after here. So this will not run. If game object is empty, do not run this. Just stop running the code. But if it is not empty, if I find something, then we'll do this stuff here. All right. Save. Let's look somewhere further down. Here we see float Horace. This is a variable being created inside of a method, which means this can only be used inside of update. And I'm saying Horace, which is me just saying short for horizontal, is equal to an input.getAccessRaw horizontal. What does that mean? It just means if I'm pressing keys on the keyboard or pressing left or right on my joystick in a horizontal direction, store whatever happens in this variable. Okay, here's another if. And here's an if else actually. So it says, if this thing, do this. If not that thing, then do this. Because we've got the else in there. Okay, let's look at maybe this. In here we can see this is a method called setup, and I'm passing information into it. This is a method, and we know it's a method because of the void. It's a method called fill dialog, and here's the instructions. There's my update. Here's another method called click more. So I've just got a bunch of methods that I keep calling on throughout this. For instance, fill dialog. Where is that? That's up here. This is a method that's being called on by this method, click more. And click more is only run from inside of Unity. Click exit is also run from inside of Unity. But we can see here, click exit is also being run in update if I press space. Anyhow, though there are tutorials for all of these scripts that I was just showing you, the dialog panel, the player script, there are tutorials for those where you can go and watch them. I just need to wrap up my beginner scripting tutorial. We've gone through our libraries up here. We've gone through our variables right here. We've also gone through making variables and methods public so that things outside can use them. So we've done our libraries, our variables. We've done some methods. Where did that go again? So here we see we looked at some methods. We also looked at functions where a method can return information. We have looked at classes. So we created a class, and we also looked at this class as well. And classes can be information because they store variables and methods. Okay, so classes, we looked at lists, collections. We looked at specialized lists, where we can use a class in a list. And we looked at two different types of loops, the for loop and the int loop. So, I must say this on loops. Be very careful when using loops that you do not do something that will cause an infinite loop. If I said minus minus, that means subtract a number. It starts at 0. The next time around, it'll be minus 1, minus 2, minus 3, minus 4. And we're only going to go as long as I is less than the student count. Well, minus 4 is less than student count. Minus 5 is less. All the way to minus infinity is less than student count. So be very careful that you do not create a loop that will go on for infinity. Always leave your way to get out of the loop. That is it. That is all. The next tutorial I want to do is going to be kind of describing how using pixel art, which I tend to use pixel art for myself, how does artwork go from a program like Photoshop or Sprite, which is what I use, how does it go from there into Unity, and how big is it in Unity? How big are your graphics in Unity? So that's what we're going to be getting to in the next tutorial. That will be it for today, and I will see you next time.